Up to now we saw how to create row vectors and column vectors, that is 1 by n matrices and m by 1 matrices. Okay, so here we see how to create other size of matrices. Let's say I want to create the matrix with first row 1 2 3 and second row 2 4 5. We can just do it by, okay, so here we will label it by A. We will say A equals, okay, I use the square bracket as I did with vectors. I'll give the 1. First row I can use space or comma to separate elements like I did with vectors. Then I have to go to next row. This is the first row. To go to next row I'll just use the semicolon. Okay, we already used this when we created column vectors. Now 2 4 5, I want you to see how MATLAB displays this, so I will not use a semicolon here. Okay, so you can see we have a matrix A here with first row 1 2 3 and second row 2 4 5. Okay, so there are some special operations that associated with matrix. You can see here its size is 2 times 3. Okay, so but I can use size of operator to get the size. Okay, let's say I get the size of A and assign it to variable t. Okay, size A. Okay, no, simple A. Okay, see, it's a 2 by 3 matrix. Okay, so I got 2 and 3 assigned to vector t. Okay, this can be important. This has some important nuances I will show you in a minute. Then there is this method. There are few methods that we can create some important matrices. Okay, one method is ones. So if you just say x equals 1, it will return a 1 scalar. Okay, and if I say ones and n, it will return a n by n matrix of ones. Okay, so for example, if I say x equals 1 once, I get a 1. Okay, and if I say x equals let's pick a size 3. Okay, I get a 3 by 3 matrix of ones. Okay, and if I say zeros, we return a 0, and if I say x equals 0 times some sides, this time let's pick 5. Okay, I get a 5 by 5 matrix of zeros. Okay, sometimes we want to, okay, same way if I want and 5 by 2 matrix of 0, sorry, C. Oh, I cleared all my variables. Okay, so, okay, C and C, sorry. Okay, accidentally I cleared all my variables, but that's okay. Okay, so if I want a matrix of, okay, I can go up to command 0, and if I want a 5 by 3 matrix, I can get a 5 by 3 matrix of 0. Sometimes there are situations where we want to create a matrix of ones or zeros of a certain size of other matrix. Let's say this X is 5 by 3. I want to create a matrix of same size, okay, and if I don't, I can use this size of operator like this, okay. I can say y equals 1, not size of factor, sorry, size x, let's say x, okay. If I do this, I will get a matrix of 1 as the same size, okay. Remember this trick, it's can be helpful sometimes. Okay, then we have this random function. If I use x equals rand, it turns a random scalar drawn from the uniform distribution in interval 0 to 1. Okay, so hope you'll know what is uniform distribution in interval 0 to 1. So you can generate a numbers using different distributions, no? Okay, so this one generate a random number from the uniform distribution, okay. In open interval 0 to 1, okay. So we'll go to MATLAB. So if I go x equals rand, okay, I will get a random number between 0 and 1, okay. So it's a randomly generated value, okay. And if I do say 3, I get a random numbers, matrix of random numbers, 3 by 3 matrix of random numbers drawn from the uniform distribution from interval 0 to 1, okay. And if I want a matrix of let's say 3 by 2 matrix of random numbers, I can say y equals to rand 2 by 3, okay. Then we will discuss about matrices later, more about matrices. There is one operation that is useful. We can transpose a matrix, okay. So we can use transpose operator, so that is just a dash. So this is a 2 by 2 matrix. If I say y dash, it will get transposed, okay. So flip, no, this y had what, 2 rows and 3 columns. This one have, sorry, the y had 2 rows and 3 columns. This one have 3 rows and 2 columns. If I look at the first row of y, it becomes the first column of y dash, no, see, okay. And the second row of y becomes the second column of y dash. So these rows and columns get interchanged, okay. And sorry, if I look at this one, first row is the first column of this, so rows and these get interchanged, okay. Now this is also important. From this we can get a row vector, we can convert it to a column, or a column vector to a row, okay. So we'll clear the screen. So for example, if I have a row column vector, if you recall how to do column vector, let's say b equals 1 semicolon 2 semicolon 3. Now this is a column vector. I can do b dash and get a row vector. Okay, and also I can use this to convert a column vector into a row vector into a column one. Okay, let's say I want to create vector of random numbers between column vector containing even numbers between 1 and 100. Okay, we saw how to do that using the dot operation for a row vector. Now we can just get the row vector and transpose it. Okay, so we can say a equals, okay, we can put the bracket or we can leave it. Okay, if you want you can put it, or you can just do this. So I'll go 2 because between 1 to 200. Okay, so this is column vector. Okay, let's say do 2 to 10 so we can see the transpose. Okay, 2 to 10, so this, and I can do a dash, I get it transposed. Okay, so we can use also linear space to get a row vector and get it transposed. Okay, so now I am going to create a sign table. Okay, so now think that, okay, so now I want to create sign table that lists degree values from 0 like 30, 60, 90 like that one up to 180, and their sign values. Okay, so the first thing to note that sign function of MATLAB takes radiant inputs. Okay, for example, if I do pi, this is for pi. Okay, we use pi for simple pi for 5, pi over 6, that is sine 30 degrees. No, this value, okay, I used the wrong bracket, sorry. Okay, so 6, I get 0.5. Okay, so the sine function accept radiant values. This is the value of sine 30. No, so if you try to do sine 30 to get this, it will not work. Okay, so see, it's not the value of 30 degrees, no, because it will give the value of the radiant 30. Okay, not 30 degrees. Okay, so we have one, I want to list the degree values in a one column from 0 to 180 increasing by 30, and then list the sign values in the other column. Okay, so first, to get first row, I have to start from 0 and increase 30, increment do increase by 30, no, do increments of 30 until I reach 180. Okay, so that vector I can easily create here using the, first I will create a row vector. Okay, because I can use this colon operation, 32, 80. Okay, so if I do this one, I can create this one. By transposing this, I can get my column. Okay, now I need to convert. Okay, so what I'll do, I'll create a table. I'll say equals, recall that we can use vectors to create a vector, no? I say, so I can say x dash, okay, then the next column. Okay, so I flip this one, so this will go in as rows, and then I do sign. I cannot give x dash. Okay, if I give x dash, it's not so I'll do x dash. Okay, and I multiply this by pi and divide it by 180 degrees. Okay, okay, so you can see that we created the column vector. So, okay, table of vectors. I forgot to mention one thing. Okay, MATLAB, this multiplication work as normal scalar multiplication. Okay, so for example, if I have matrix x, if I multiply by pi over 5, each element get multiplied by pi over 180. Okay, so you can see sine 30 is half, sine 60 is 0.866, and sine of 90 is 1. These values are correct, no? Up to 180. Okay, then coming back to what I was mentioning, so for example, if I multiply x by 5, each of the element in x get multiplied by 5. Okay, see, 150, 300, like that. So here I do x dash, I get a column vector, and then each element in that column vector I multiply by pi over 180 degrees to convert it into radians, no? And I convert it to radians and feed into the sine function. Because sine function takes a column vector, it returns us back a column vector. So that column vector goes here. Okay,